guys going on? Mike the Caveman Q here again from Paleo Problem Island, MikeTheCaveman.com. And today's question is nutrition science broken? So, what do I mean by that? Well, when we're talking about research, and I love digging into the literature, digging into the research, and trying to find mechanisms of how things work. The problem with nutrition science is that it's super tough to use the gold standard of traditional research, which is the randomized controlled trial. If we're talking about a pharmaceutical drug, it's super easy to say, okay, you're in group 1, you're in group 2, not tell the person actually conducting the test, and then give them the medication that they're supposed to get, and not find out until afterwards. Super easy to design that. If we're talking about chemistry, it's super easy to change the variables. Okay, this chemical, we're going to react it with this one. We're going to react that one with this one now, and see the different results. Super easy to design that experiment. If we're talking about physics and you want to test gravity, it's super easy to change that variable. Take two objects. They weigh completely different amounts, right? We have a crumpled up piece of paper and we have a 5-pound medicine ball. We drop them, they drop at that same rate, that 9.82 meters per second squared. If you want to change it up, you want to see if other factors can be involved, let's say if paper's not crumpled up, well, now wind resistance changes the rate at which it falls. Gravity is no longer the only variable. So if we're talking about nutrition science, the problem we have is that unless we are locking our participants into a metabolic ward, which we kind of phased out with the Nuremberg trials, good choice, but it's kind of tough to actually run a randomized controlled trial with nutrition in humans. There are too many variables that you have to control for. So, what is the gold standard in nutrition? Well, unfortunately, it's a type of study called an observational study, meaning that we observe free living humans. Good thing, freedom, yay. So what happens? We watch humans and pick an exposure or a variable, and then we look for a certain outcome. We then run statistical analyses on those to determine whether or not that exposure is associated or linked to that outcome. Now, the problem with this method is that correlation, that association, does not necessarily equal causation. There are a lot of factors involved. Now, there are methods of controlling for this confounding, but they are not always ideal because perhaps we are not looking for the right variable. As a good example, if we're talking about red meat and colon cancer risk, a lot of data shows that red meat, particularly processed red meat, is associated with the increased risk of colon cancer. My biggest problem with these studies are the fact that the food questionnaires used are not particularly accurate. What do I mean? Well, if you actually look at one of the questionnaires, whether it be the Willett FFQ, the DHQ, or the Block FFQ, all of those use very vague and very confusing definitions of each of the food items. Included under the red meat umbrella would be things like mixed products such as lasagna, stews, chilies, casseroles, pepperoni pizza. Yeah, pepperoni pizza is a meat. Right. So from there we start to see where it starts to get a little bit squirrely in determining what the factor is. Now, using statistical analyses, there are methods of isolating each of the individual components. And that is a major part of what those studies try to do. They try to use multivariate analyses to break down and decipher what it was that actually caused the problem. Now, besides the ambiguous definition of red meat using things like casseroles, pizza, and lasagna, let's consider the fact of meat quality. We have talked ad nauseum about the differences between grass-fed, pasture-raised, organic red meat and conventionally raised factory meat. They are completely different things on a biochemical level, and they have different factors in our bodies as well. They have different fatty acid profiles. Grass-fed red meat has higher levels of CLA, or conjugated linoleic acid, which is a molecule that has exhibited anti-carcinogenic activity. It has higher levels of omega-3 with greatly reduced levels of omega-6. So it has a better omega-3 omega-6 ratio, meaning that it is less anti-inflammatory. So the real problem isn't that the researchers aren't inherently trying to deceive you, though. That's why I didn't have to break the tinfoil hat out today. It's more that there's only so many variables you can look at and or control for at a given time. And because we can't use randomized controlled trials to their true efficacy, it becomes really difficult to look at nutrition science. So your biggest takeaways for today, though, are that when you see that study hitting the media, understand that it's been filtered through a number of limitations and a number of different sources. First is the actual data. What does the data say? Next comes the scientist who's actually writing and interpreting that data. Next comes the press release that gets released out to the public from those scientists, but it's written by somebody else, a scientific writer on staff, which then is disseminated to the rest of the media who have to interpret it from there, generally with a lack of understanding of the scientific groundings upon which it's based. So that's how we get things like red meat causes cancer as bad as smoking, period. No, it doesn't. Not a chance. It's also part of the reason how we end up with whole grains are good for you. If you're replacing pasta with whole grains, then yeah, you're going to see better results on the insulin levels. And particularly if they are properly prepared, you're going to get better results and better outcomes. But if you're replacing your vegetables with whole grains because you think they're healthy, then there's a problem. So the problem with nutrition science, like we said, is isolating those individual variables. There are statistical models to do it, but there are so many things that can happen from a biochemical and physiological perspective. That is why I use that ancestral framework. It gives us a base upon which to build hypotheses. From there, we look to what the actual data says, and while for nutrition science, the gold standard is generally observational epidemiological studies, I like to look more at what the biochemistry says. How does it actually affect our bodies once it gets in there? Not what do populations show. From there, actually look at what it does to your body. That's why n equals 1 equals the top of my pyramid. I want to know, how does it affect you when it gets to you? So that's the biggest takeaway. Do not necessarily get freaked out every time you see a new study pop up saying this is bad and that is bad and this is good and that is good. Actually dig a little deeper. That's your homework. Either way, hopefully that helped you out. You know what to do though. Like and subscribe down below. Share it with your friends. Head over to Instagram and Twitter and follow me at Mike the Caveman, over on Facebook at Paleo Problem Long Island, and of course over at MikeTheCaveman.com. That being said, have a wonderful rest of your day. Focus on your health, stop stressing, and I'll see you tomorrow.